Okay, so we're going to talk about now CyberSense. CyberSense is really, we've been using AI for many years. I mean, you go now to conferences and all over the place, everybody's talking about AI. We've been talking about it for at least 5 years now. Again, my name is Jim McGann from Index Engines. So this is a slide that we use a lot to educate our customers and to understand why you need this level of data integrity and why you need the level of analysis of the data. You need to understand the variants that are being used. And I update this on a regular basis because there's all sorts of new ones that come out. But something like AlphaLocker has been around for a little bit. They maintain the original metadata properties. So when you look at a file that's been corrupted by AlphaLocker, I'll show you an example of that. It looks the same. It has the same extension, the same size, all the same information. And if you're inspecting it using some of this lightweight inspection, it's like, hey, it looks good. But it's not. White Rose does slow corruption. Slow corruption is probably more difficult to detect, because if you're using things like threshold, rates of change of data and things like that, something like White Rose does, less than a file per second. Very slow, methodical type corruption. Most of them go in and do fast and furious kind of stuff. They just want to get in, get out. These three on the bottom, so based on our research lab, what we see is these three on the bottom represent about 60% of the variants that are being used. And realize the folks that are the bad actors, allegedly Russians, allegedly Korea, allegedly China, have a bag of tricks. They have this whole shelf of stuff that they could use. And then they can use Gen AI to kind of modify it and create new ones. But we're seeing 60% are these types of variants. Exodus is one of the more sophisticated one. If you're familiar with different types of encryption algorithms, XOR encryption won't change any entropy or compression rates of the file. So a lot of vendors are saying, hey, we analyze the compression of the snapshots or the backups, and if it becomes highly compressed, either a user created a lot of files into zip folders or there was encryption going on. But something like Exodus won't be detected at all. It doesn't leave that footprint of those fingerprints behind. Chaos uses base 64, which just minimizes entropy or compression rates. And Lockfile and BioLion this is a couple of years ago, this came out, and it's doing partial or intermittent encryption. So, if you're using different approaches like inspecting metadata, you're not going to see AlphaLocker. If you're looking at thresholds to look at rate of change of data, you're not going to see White Rose. If you're using compression rates, which is commonly used, you're not going to see any of these variants. So again, that's a conversation that a lot of these vendors have. And I have it with vendors too that we're looking to partner with. They're saying, well, we're just going to do good enough, where there's good, better, best. We know you guys are best. We'll do good enough just so we check boxes on a, like a, RFI saying, hey, yeah, we have ransomware. This is the kind of stuff we check. So with CyberSense, obviously, we tout this deep content analysis, and it's for this reason, to find this level of variance. And again, when I present, customers say, I had no idea they were doing this level of stuff. And I'm like, you really need to have an idea. And when we present to the CISOs or the security teams, they know this stuff. They're like, you can detect this stuff. One of the biggest vendors out there just announced some new capability that they're analyzing for variance, and they used the variant that's very old and easy to detect. And I'm like, that was their example. I'm like, that's, it's child's play to be able to detect that stuff. That's what you're going to kind of tout as your resilience. So, these are the ones that we talk about and we track. So with CyberSense, again, it's AI-powered data analysis. We can't do what CyberSense does manually. It needs automation. It needs intelligence. It processes millions of data points. CyberSense wants to see data at rest, wants to see an observation of data, whether it be a snapshot or a backup, right? So it's a data at 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, compares what it looked like before, how it changed. And that's part of the analytics that are being used. So again, observations over time, deep inspection of files, deep inspection of databases. A lot of customers are being told by their vendor, and I was just speaking to a Gartner security analyst, and they said they're telling the customer that databases don't get attacked, and if they get attacked, you'll know it just won't run. And I'm like, those are absolutely false. They are. If you're a cyber criminal and you want to shut down an organization, go for their SAP HANA database or Oracle database. That's, you're going to get their attention, right? And you could point any variant to a database file, it just looks like a file, and it's going to intermittently encrypt through pages of the database. It doesn't care if it's a database or a PDF, it's going to do the same thing. Oracle runs in production if you have pages encrypted inside there. It will continue to run. Unless you hit that page or hit that record, you're not going to know it. So, these vendors are telling customers that, and it's like they're telling them that because they can't do it. And they say, oh, you don't need to do that. The number one source of data that we're seeing customers protecting is databases. Infrastructure as well. Active Directory is a database structure. Again, we do metadata-based analytics, which a lot of people do, but then we do hundreds of content-based analytics looking inside the files. Critical differentiator. So again, and I'll talk a little bit more. I mean, Christy, you were talking about the 99.5% confidence. We train this on thousands of variants. So we have a process which I'll talk about in our lab. Jeff mentioned going onto the dark web, going into other sources, and just finding all the new variants that exist, executing them, real-time execution, tested against millions of data sets, continual feedback. We do get feedback from customers on their data to provide that 99.5% confidence. Again, it's a real number, not a marketing number. So the way we train, so the question you want to ask, if you're talking to other people that say, hey, we have AI and machine learning, the question you want to ask them is, how do you train that? Because on day one, machine learning has no information, and it just gets smarter as you start training it and giving it information. That's the way it works. So we're very, very specific about how we train the machine learning. We use subscription services. So VirusTotal is a great one. It's a Google-owned property. So if you as a customer get a ransomware, what you'll do is, it's part of your process is you'll upload that variant to VirusTotal. And then the community there, it's crowdsourced, will talk about it, analyze it, and study it. And all the new variants go there. We download it from there. We use academia, global research. There's a lot of people using Twitter or X now, bloggers. We go on the dark web. We just find the stuff. And then we get a bunch of anonymized customer data. So that is a continual process. I'll talk about that in more detail. That's fed into the machine learning to continually train it. It's not a one and done process. You need to continually train it to understand. The beauty of that, though, is that what they've typically done, the bad actors are doing, doesn't generally change. The patterns are pretty much the same. So recognizing the patterns is easier. You just need to continue to see if there's new patterns or train it on new names or new types of encryption. Then from the customer side, we scan files and databases, including inspecting the header, inspecting the content, inspecting the metadata, create all those data points. So you get millions of analytics input that are fed to the machine learning. Together, they kick out a determination, is the data clean or not clean, with 99.5% confidence. So there's a lot of processing that goes in, a lot of analysis that goes into the data. But at the end of the day, that you're going to say, hey, the data's clean, the data's good, normal, it's going to be a normal day here, or the data's not good, and I know exactly what happened to recover.
So Ben Story here with Red Eye Networks. So I know we're detecting the files that are being encrypted. We're seeing the canaries dying as it goes on. Coming towards the recovery side of things, are you able to pinpoint and help the recovery teams determine what backdoors have been left behind in the systems?
Yeah. So with CyberSense, when you scan the data, every file that's scanned, whether it be a PDF or a Word document or the actual ransomware, gets a signature assigned to it. So when you in the recovery process, you could upload signatures into the CyberSense index, and it'll tell you if any of those signatures, ransomware, exists in the backups.
Okay.
So,
but are you looking for just ransomware? Or are you looking for things like beacons and the persistence that the hackers try to put in?
Yeah, it'll if you have listing of signature of all that stuff, it'll find everything that it scans has a signature.
Okay.
So again, CyberSense is looking for the data corruption. It's not necessarily looking for the ransomware, but the fact that you have a signature for beacons or malware or anything like that, it'll say, yeah, it exists. It's right here. Don't restore that back into production, right? But we assume that customers are having lots of security tools in production to find this stuff. It's not 100% effective. I think signature scanning, the stats I saw were like 45 to 55% effective in finding signatures. If you go and you download a list of signatures for malware, it takes them 2 seconds to modify the malware. I mean, you just change the name of it or you change whatever, and it's like the signature is invalid. So signature scanning is very, people think that's like the end all. It's like, oh, it'll find it. It's like, 50% effective is not a good, resiliency strategy. So, but in the recovery process, by the time you recover, you'll know what you were hit with. You upload those signatures into CyberSense. It'll say, hey, it exists in these backups, and don't restore this into production. So again, I was talking about this, our research lab, again, 99.5% confidence. So what we do in the lab, and this happens on a daily basis. In fact, this whole process is automated process. So it's just a continual process that runs, is we've done research and we look at the different behaviors from ransomware. There's really a set number of types of behavior. They'll encrypt the whole file and obfuscate the file name. They'll encrypt it and maintain the file name, kind of patterns of what they're doing. So we've defined a set number of patterns. We classify them. They're classified into 5 categories of what the bad actors are doing. We collect 2 different types of data. We collect user data, databases, files, PDFs, Word documents into a testing environment. We also collect the variants, the actual ransomware. So we have a dirty network that we execute this ransomware on. Then we generate either backups or snapshots of them. So the lab, our folks in the lab know what data is clean, know what data has been corrupted, so they have those stats. And then we use CyberSense analysis, and we come up with the testing results of 99.5% confidence. If we don't get 99.5% confidence that it's detected what's been corrupted, then we need to do some training on the machine learning. But you typically don't, customers say, hey, do I need to update the machine learning every time I scan the data? It's not like signature scanning. This is looking for patterns that are pretty well defined. So if you don't update the machine learning for weeks or months, you're fine. But we do regular updates on the machine learning. It doesn't need to be updated every time. So again, there's over 200 metadata and content analytics that are being used. Again, comparing data, how it changes over time, generates millions of data points, which is really the fuel for the AI engine to make deterministic decisions on it. And then again, output with highly confidence that the data is clean or not clean. So this is the example I mentioned, Alpha Locker before. Alpha Locker is commonly used. If you look on the left here, you'll see that this is a pre-attack version. This is a clean version of this file. On the right is a corrupted version of the file. So if you come and you say, let me look at this and see, has this been corrupted? You don't know yet. The file name is exactly the same on the left and the right. So the file name is identical. It's like, they didn't change the file name. You're used to them appending like .lol extension or .encrypted extension. They didn't do it here. The file size is identical. So if you're looking for a large change in file size, didn't happen here. But again, the importance of content is that if you look at the file type is defined by reading the header. That's where the true file type is stored in the header of the file. So that's a content header. Here on the left, it's a SQL database file. On the right, it's unknown. So CyberSense says, hey, something happened. This file is now unknown, which could be some error in the file or something. It's like, I'm not really sure. But at the bottom, we have an entropy score, which is rated from 0 to 99. So the entropy increased from 45 to 99. So it was a large increase in entropy or encryption with a corrupted header. That's something like Alpha Locker. You'll get an alert. So again, the inspection here of the content was critical in determining that this file was corrupted. So again, databases, I mentioned, this is, if you think about the power of CyberSense, talking about what we do with databases is the most impressive aspect of what CyberSense does. So again, CyberSense is going to look at the header of a database and say, hey, this is a Oracle or SQL database or DB2. Does the structure look intact? Yes or no, right? But it goes inside and starts looking at the pages of a database. So it'll look and validate page signatures, allocation map, validates the headers, make sure they're intact, and compare them to the previous version of the database. Again, looking at the content, it validates the page headers, looks to see if they're encrypted. So if you go in and you randomly encrypt pages inside of an Oracle database, again, the Oracle database will continue to run in production. if a user tries to access that patient record or that insurance record, and that page is encrypted and they just get an error, they'll be like, stupid database, and just move on, not realizing that's a ransomware attack, they're being corrupted. But here, CyberSense would tell you that these pages have been encrypted and there's corruption going on inside here. And this happens, again, most of our customers focus on protecting databases as their priority because that's the crown jewel data. And most other vendors really don't. This is hard to do. Most vendors don't do this. And this is why CyberSense wants to look at point-in-time snapshots or copies. You really don't want to do this on a production database. This is running in production. You need to see a copy of it, a static copy of the database, and it compares it. So this is probably when you look at what CyberSense does, again, it's like peeling the onion. It's going layers and layers and layers deep to make sure everything is good. And that's the confidence that CyberSense provides. Again, this is the output of CyberSense saying, hey, this is an Oracle database. What you see in red is specific pages that had corruption. So you'll know exactly what time and what was specifically corrupted here. So again, the forensic analysis of what CyberSense provides is incredibly detailed. And the mystery of an attack, the mystery of what happened, what got corrupted is gone. CyberSense tells you, I'll tell you exactly what happened here. So typically, with CyberSense, we don't sell CyberSense direct. We sell it through partnerships. They're usually strategic partnerships. Customers want this integrated with their production storage or integrated with their DR or their backup processes. That's where they want it. So we have partnerships today with Dell, which is our most productive one. Chris, I know you guys did some research for them. We have thousands of customers globally that are using this with Dell. We have a partnership with IBM in their flash storage, their safeguarded storage, where it's a different deployment. And we have flexibility in our partnerships, whether it be part of the backup process. So CyberSense can scan backup images, whether it be Commvault, whether it be Networker, whether it be Spectrum Protect, without rehydrating the data. So it goes inside there. And again, as Jeff mentioned early on, it supports very complex formats and getting inside those containers to index the data without rehydrating it, which is important because you don't want any malware that's in there to potentially continue to spread. With partners like IBM and Infinidad, it's with their flash storage. So it's not backup data, it's just snapshot data that's being analyzed on a regular basis. So the workflow is similar, and there'll be other partnerships that we'll be announcing over the next few months. But in those conversations with those partners, they look at our technology and they say, again, we have some stuff that we think is good. You guys are best, the best in breed that's out there. And we have a lot. We do a lot of work with the analysts like Futurum. Sorry, I'll still remember you as evaluator group. Sorry, Krista. Futurum and Gartner and other IDC to educate them on this capability exists out there. And it's it's easy to integrate with these partners. We just need to see a copy of the data at rest and scan it, and that orchestration work. And we're simplifying that orchestration work is something that's easily integratable. But the workflow is pretty straightforward. Everything we have that I'll show you in our interface is available through APIs. So APIs are available for all this, the alerts, all the information that CyberSense provides. Again, comprehensive index is generated, highly efficient. Again, there's over 200 analytics or statistics generated every time. Machine learning is being fed those statistics. And if there's corruption detected, you're going to get an alert. So typically in our partners' dashboard, you'll get an alert, click it through to the CyberSense dashboard, which I'll show you. That'll give you all the detailed information of exactly what happened. And then the post-attack forensics, again, is all the nitty-gritty of exactly what happened, what you need to do to recover what was infected. It just takes away all that mystery. And when we talk to customers, they're like, I just happy to have all that, one, the confidence, and two, all the information I need, in order to recover and get back into production. So this is the dashboard. I'll show it to you in a live demo. But on the top, you get the alerts. So one of our 8.6 release, which was announced yesterday, has new types of alerts. They're kind of threshold analysis, which I'll talk about. But the severe alerts are going to be a ransomware attack. In the middle, you'll get a description of why CyberSense released that alert. It said this is exactly what happened. And the bottom, you've got the detailed report of this is what happened. So in this case, there was 31,000 885 files that were corrupted across 3 hosts. And you can drill in, what do those 3 hosts look like? So again, in terms of like a recovery, you were mentioning the process, I'm like, well, it's these 3 hosts. So that one host was the finance server. Let's get that up and running right away. Those other 2 hosts were, nobody really uses that. It's an archive marketing server or something that we can wait on that. So you have an idea of exactly what should be recovered. And customers sometimes say, well, why don't you just automate the recovery process? You really want to kind of have human intervention there to figure out exactly what happened. You don't want to automate a recovery of an Oracle database. You want to say, well, let's see exactly what happened to it.
That's Sherry Benoff from the Future Room Group. Do you also identify the point of infiltration of the bad actor within the organization as well in order to find out where the entry point is or was?
So that's some of the telemetry data that CyberSense provides. So it's going to give you the blast radius. Like this is the content that was corrupted, and this is the time. So if you use some of the other tools inside, that's where the security teams lean into this, saying here's the 31,000 files that were corrupted, an exact date and time. You can export this. I'll show you how to do that, and they can say who was the last user that touched these files, and that's the breach user account. So we don't have that because that's usually in the event logs, and customers don't typically put the event logs in a backup or snapshot. It's just too dynamic.
So you're able to backtrack to really pinpoint it.
Right. And then they can say, hey, these 31,000 files were modified. What was the exe or executable that modified them? That's your malware.
Yep.
So you can, if customers don't know where it is at this point, they can use the telemetry data to figure that out, right?
That's good.
So, if we had the event logs and that kind of information in like a vault or in a snapshot, you could do that, but customers typically don't do it. The security teams are happy to get the telemetry data and say, I'll figure that out, just give it to me.
That's interesting. Usually, based on training within organizations, certainly when it comes to the employees within organizations, they would like to train them and really understand who's at risk, and everybody really is in cyber threat risks within the organization.
Yeah.
It's interesting that they didn't ask for it.
All the information's there. It's kind of, you're doing like Inspector Clouseau kind of figuring it out. But, if you have, the teams that we deal with on the security side are some of the smarter people you're going to see in IT. No offense to everybody else. But they just need to, they live and die by this information, and they want to, again, it's open warfare for these guys, right?
Yeah, thank you.
I had a quick question. So, we're talking about it with Dell and different storage. How does this work with more like NAS-based solutions too, right? Like Synology, NetApp.
Yeah.
Sometimes, we're still seeing malware attacks and different types of ransomware attacks with
Yeah.
that as well.
So one of our next announcements that's coming in our little sneak preview here in our 8.7 release is kind of more of an integration toolkit. So these vendors, like an example, someone like NetApp provides capabilities like snapdiff capabilities that if you can feed that to CyberSense and say, here's the data that changed, go and scan that data. So it's the APIs that we have will integrate to some of their capabilities and say what data has changed and been modified. That's the data that will be scanned. So there's a bit of orchestration and tying this stuff together that needs to happen. But the goal, and I know Jeff's team is working on this, is to be able to provide a developer toolkit that allow customers to integrate with all different classes of storage.
Okay.
But again, we'll provide the orchestration capability. It's just the last mile where they'll need to connect it into these environments. So, again, it's really about what data has changed that needs to be analyzed. Because if you're connecting to like a petabyte of enterprise storage, you don't want to scan it every day. There's no need to do that. If it's a 2 or 3% change rate, just give me that information and I'll scan that every day. So it's that kind of collaboration with the software that's important, right? So in terms of smarter recovery, when there is an attack, there'll be an alert generated. Usually our partners integrate that with their dashboard that they have, that customers are monitoring their storage or their data protection, saying, hey, it's usually red light, green light kind of thing. Red light, we've got a problem here. There's email alerts that come out. Some of the larger customers integrate, through syslog to their SIM or source systems. So, we have a large airline that has, 30 or 40 CyberSense servers running, and they're like, I'm not going to be looking at these dashboards. Just give me the data into my security systems and make that part of the normal workflow that they can understand exactly what's happening. And that's already being monitored. This just gives them extra layer of information to be monitored. And I'll show you this in the demo here. But again, here's the dashboard. I went through that. So this is really what you're going to look at. So these are the backups or snapshots. So again, it's like red light, green light, right? So you get clean, clean, clean. Up, there's alerts on these. So this, at this point, you'll know that there's problems with these. Hopefully customers don't get 3 backups in a row. But you can click on this and then go to the detail of exactly what happened in the backup. So again, a lot of vendors out there that are doing data protection are saying, hey, that backup, it's red light, bad, just put the previous one in, and not give you the forensic level of details of what happened. Was it 5 files that I'm need to restore, or just, where I'm doing the whole backup, which is, could be thousands and thousands of files. They don't necessarily all need to be recovered. CyberSense will give you the details of exactly what needs to be recovered.
I don't know, maybe this is just a hypothetical, and answering hypotheticals is not worth it, but what if we started using your product, but we were already experiencing some sort of ransomware event, like one of those low and slow ones, like you gave an example of. So, normally you would want to start using this product when you have a nice clean baseline to be able to see those changes. What if the baseline, what if we've already introduced your product into an environment that already has ransomware slowly crawling along? The baseline has a rate of change in it already.
That's a very good question, actually. So we have a number of different machine learning models. One of the machine learning models we have is a 0-day, day 1 scan. Now look at that. So you're not going to get 99.5% confidence in detecting corruption because it doesn't have a comparison to other versions. It's building out the baseline. And what we'll see is different things. So there may be, and it happens rarely now because we've really seen a lot of files, but the machine learning may scan it and may say, hey, there's a bunch of files I've never seen before because no one's ever trained me, Mr. Machine Learning, on those files. So tell me if they're good or tell me if they're bad. And we have one customer based out of Israel. They're a transportation organization, very large, high-profile target. Day 1 scan, there was a bunch of files that CyberSense saw. Said, hey, I see a bunch of files here. I'm not really sure what they are. Are they good? Are they bad? I don't know. Mr. Customer, you go tell me if they're good or bad. And we can then update the machine learning if they're good and say, hey, those are good. Next time you see them, they're good. It happened to be a bunch of Russian malware that hadn't executed. So CyberSense didn't send the alert and say, hey, you got Russian malware there. It said, hey, just go look at that stuff. And the security team says, yeah, thanks. We didn't see that. And they had tons of security tools, right? So there's that. They could either be on day 1, they could actually be actual malware that's there or corruption that exists. And we see that pretty frequently. We see some customers that come to us and say, I've been attacked. Can I use CyberSense to start scanning the backups and going back in time? In that case, you do want to create the baseline, but you have to kind of manually go back in time and figure out where is the clean baseline and kind of build that up in the comparison. So yeah, it's definitely a process, and CyberSense is assuming that day 1 you're going to get a clean baseline, but it's not always the case, right?
So in that case, how long does your product need, or how long do you recommend building that baseline? I mean, on day 1, there is no baseline.
Yeah, that's what I was going to
So
ask.
Yeah.
is it 1 week, 2 weeks, a month?
No, I mean, day 1 should provide a clean baseline. If not, you're going to get the machine learning algorithms. The one we have that's going to look at day 1 scan will provide you an alert if it sees corruption.
Okay.
Again, so on day 1, do you have anything to add on that, or?
Well, I can, just step up.
Yeah.
Jeff Barrell, Chief Product Officer. So we've done a lot of testing on this, and I think it's a core point of differentiation for us versus the competitors. We're about an order of magnitude better than most of our competitors in this regard. So most of the other solutions require several weeks, but we're really good to go in just a couple of scans. And then we're good to go because of this day 0 model that Jim talked about. So
Yeah, that's what I wanted to hop on too. Like he said, once you drop it in the environment, does it start pulling data right away to go, okay, something's off, whether it be a file extension or something, or does it take a couple days? Like, let's just gauge like a day or 2 to start really compiling that data, and then, okay, we're noticing we see some trends or patterns, something's off.
So things will definitely improve over time. So as you get more data points, as the index builds up data, things are going to improve. But we think we probably have the best day 0 model in the industry right now. So our odds of detecting, suspicious malware the first time we run is much better than any other solution that's available. But it's absolutely the case that over time, the more time that passes, the better we'll get, just the same as any solution in the space. So.
Yeah, the day 0, the initial scan has 95% confidence in detecting corruption, which is still very high. you know, and then once you get another snapshot or backup, it's going to go to 99.5% confidence because it has a comparison baseline. But if things just don't make sense on day one, you're going to get an alert saying that there's already corruption that exists here, and it happens all the time that they see that, and then they, you know, I mean, you know, it's highly confident in finding that corruption on day one. You know, but it's the best level of confidence you're going to have is if you have comparisons of those snapshots or backups.